So the first video for week 3 is going to cover some of the useful objects that you will be using, not just now, but throughout the entire course. This is the pack and unpack object, the metro object, and the int and float objects. So let's start with the pack and unpack objects. Pack is an object that is designed to take multiple inputs and combine them into a list. And unpack does the reverse of that. It takes a list and it separates the list into the individual elements of that list. Now, pack and unpack are objects that can have a variable number of inlets in the case of pack and outlets in the case of unpack. So however many arguments you give to pack, it creates inlets that correspond to those arguments. And similarly for unpack, it creates outlets. So each of these have 4 inlets in pack and 4 outlets in unpack. And if we were to add another argument to the end of this, we'll call it 0, there would be another outlet created. All right, so we'll take that away. All right, so like most of the objects we've come across, you store values from right to left, and it's only when a value comes in the leftmost inlet that pack will create the list, and it will create the list with whatever values have been put in to either the default values or replacements for the default values. What I'm going to do is I'm going to type M, and I'm going to make a message, and just temporarily I'm going to join the output from pack into the right inlet of a message. And the right inlet of a message will set the contents of a message box. So we can just see that if I hit start and I scroll around in here, you notice nothing has come out yet. But when I put 14, click on the 14, the message of 14, 138.5, because the second argument was a floating point number, and then 138 because the third argument was an integer, and then the word start. So that is our list that's been created, and you can also see that that has come out of the unpack. And if we were to go over here and look at the print statement, we can see that it printed the word start. Okay. You can have any number of arguments in pack and unpack, and you can specify by the arguments what kind of data type your list consists of. So it might be that you're just dealing with integers, and then you would say 3 integers would be pack 000 or pack 123 if you prefer. 4 floats would be pack 0.1.2.3. Right? So that you're specifying with the argument what kind of data type you're expecting that list to contain. And this is simply up to you. It depends on what you're using your data for. But there are many, many instances in Max where we need to build a list, and we need to build the list from individual components, and we need to then pass that list into another object. I should mention that the bang basically does the same thing that putting any value into the first inlet. It will cause pack to output its values. So if I change all these just to see and hit that, it outputs the last value, the last list that was stored inside. If you just simply say unpack or pack, you will get 2 inlets in pack and 2 outlets in unpack, and the assumption is that the default arguments are 2 integers. If you look down here at the bottom right corner of the patch, you'll see that one of the nice things that Max does is that if you put too many elements in your list into an unpack, this has 2, 4, 6 elements, but my unpack only supports 2 integers. I click on this and it basically just ignores all the extra ones. It just simply says, okay, well, I don't know why you gave me 6 values, and I don't know why the second one was a floating point number, but I'm only going to give you 2 integers, and it truncates that floating point number. So you can see what happens. This is nice because it doesn't say to you, it doesn't crash on you, it doesn't lock up. It simply tries to do what is reasonable, which is to ignore all the extra values that you put in. So that's pack, an extremely useful object. The int and the float objects that you see in the middle of the patch, we've come across integers and floats as data types, and we've seen them in number boxes and flow number boxes. But this is actually an object and the purpose of this object is to store an integer or a floating point number so that you could use it later. So, for example, and the way you do that is you put the value you want to store in the right inlet of the object, and then you bang the left inlet to retrieve it. So I'm going to put a value in of 50, let's say 49, and then later on I want that value. I send a bang in, and the 49 comes out. Similarly, 8.58. Click on it, and 8.58 comes out. You can also, of course, put a floating point number or an integer directly into the int box, and when you do that, it comes out immediately. Reset it, retrieve it. Again, this is, if we compare it to other programming languages, this is a bit like having a variable, like a global variable. It doesn't have a name, but you're basically saying, I'm going to store this value, and then at some point later I'm going to retrieve that value so I can use it. A very useful, very simple, but a very useful object. Okay, the metro object. The metro object takes an argument which is the time in milliseconds that you want a metronome running at. So you have to not think about a tempo, but you have to think about durations. In other words, we have an inverse of what we normally think of as tempo. The higher the numbers you put into the metro, the slower it runs. If you put a metro running at 100, that means that the pulses are 100 milliseconds apart. In other words, you're running at 10 impulses or 10 metros a second, which is a tempo of about 600. Right? So you'll get used to it. So when I turn it on with the toggle box, you can see that it pulses at a regular interval. And if I change that, let's say, to 120, it's flashing so hard now you can hardly see it. And let's put 5,000 in, and now it's going to pulse very slowly. There we go. Okay. You will see that it's also possible to use the transport, something called the global transport in MaxMSP, and to use note values and tempos, and we will get into that maybe by the end of this week or by next week. All right, so that's tempos, or that's metros, packs, ints, and floats. The last thing I wanted to cover in this tutorial is the sequencing of messages. It turns out that if I pass this message, which says 60, 100, 64, 100, 67, 100, into a make note object, well, I did get a little error message here that I can show you. Make note, extra argument for the message list. Oh, thank you. It didn't really quite understand what I was trying to do here to the make note, because it really didn't want, it's got stuff in here that doesn't really make sense, because the channel number is 64. Actually, the duration is 64, the channel number is 100. Right? So that doesn't make sense, but it did sort of play a note, a very short note. I'm going to go back in here and I'm going to reset that by putting 1,000 back in. And then I'm going to look at this message box. And this message box is quite different. This message box says 60-100, comma, 64-100, comma, 67-100. And so this is not a list of 6 values. This is a sequence of a list of 2 values followed by a list of 2 values followed by a list of 2 values. So this is a different format. So the commas basically separate the list into smaller lists. And if I send this to my make note object, I get a chord. I get a chord because immediately, one after another, very, very quickly, a message 60-100 is followed by 64-100, followed by 67-100. And the make note object plays the C, the E, and the G at a velocity of 100 each, very, very quickly after one another, and they all last 1 second in duration. Right? So it is possible to have sequences of messages. This, essentially is a chord, and you could have chord structures by putting commas in lists and understanding that they are no longer one large list, but they're a series of smaller lists. Okay, and that's all I wanted to cover in this tutorial.